problem. And let me show you exactly how you help yourself. I need quiet, and I need Hunter awake and Thomas awake. Thank you. Okay? First thing I need you to do is I need you to take an inventory of what your problems have in them. So this first problem says, because I don't know what gas law it is until I start seeing what I have in the problem. It says 2.56 moles. Well, there's a big old fat clue. Right, because I don't have any gas law except for inert that has moles used in it. Yes? Okay. So N is equal to 2.56 MOL, and I'll abbreviate mine as MOL. And it's of oxygen gas, and it occupies 1.5 liters. That's a volume. V is equal to 1.50 L. At 28 degrees Celsius, there's my T. 28 degrees Celsius plus 273 is going to give me my 301K, and I need it just to go to the ones place because that only goes to the ones place. Then it says, what is the pressure? So I put big fat question mark beside pressure. Second thing I do is I cross out your units, okay? So see how that R is always going to have 4 units. It's going to have liters times either atmospheres or kilopascals, and in this case it's got kilopascals. So liters times kilopascals divided by mole divided by Kelvin. It's always going to have those 4 units. In the last section unit we were in, we had specific heat that had 3 units. Joules per gram per degree Celsius. Well, this one's got 4 because it's got pressure and volume and moles and temperature. It's got all 4. Cell phones are put away, right? Totally. Okay. So I come up here and I see liters, and that cancels out with liters. I see moles, that cancels out with moles, and I see Kelvin, that cancels out with Kelvin, and I circle the 1 unit that I need, which is going to be kPa. Now I need to write down my equation. So Nate, what are you doing? For what? This is going to be on YouTube. It's a video right now. You don't have to take pictures. It's a YouTube video. I promise. Okay. PV equals nRT. What I need to do is take my numbers, just my numbers, and plug them into PV equals nRT. So P is unknown, so I write it as unknown. V is 1.50. N is 2.56. R is 0.0821. Oh, no, it's not. Sorry. I'm too much in the AP mode. Sorry. It's the only one we use in AP. 8.31. And T is 301. So I just want to put parentheses around that. Now, Hunt, how do I isolate my P? How do I get him all by himself? Everything gets divided by 1.50. Both sides get divided by 1.50. Yes? That isolates my P. And Lauren, what do I get for my answer? Okay, so the unrounded answer is what? 4268.90. Anybody get that with me? Yes, no? Okay. So Lauren, how do I round that to 3 sig figs? Okay, so 42 what? Thank you. 4270 is my final answer. 4270 kPa's, kilopascals, is my final answer. Pretty large pressure. Kiara, fell off fast. 4270 kilopascals. Okay, so that one is my pub-inert question. Here's not a pub-inert question, and how do I know? Because I immediately see 2 what, Daniel? I see 2 temperatures. I see 2 temperatures. If I see, and if all ears open, because Hunter, all ears are not open right now. Thomas, all ears are not open right now. If I see two temperatures or two volumes, if I see two temperatures or two volumes, you know what gas law is going to be automatically? Combined. P1, V1, T2 equals P2, V2, T1. Automatically. Did you hear that? If I see two temperatures or two volumes, it's automatically going to be the combined gas law. The polymer doesn't have two of anything. And Dalton's law of partial pressures has pressures. It's got two pressures. So that's why I said the combined means two volumes mentioned or two temperatures mentioned. It's automatically going to be P1, V1, T2 equals P2, V2, T1. So let's take out of our equation, or out of our problem, what we have and do our inventory. I see V for the first time, and I've already concluded since I see two temperatures, I'm going to have ones and twos. So 2.30 liters is my V1. T1 is 20 degrees Celsius. You've always got to add that 273. V2, what will the volume of the N2 gas be? That's my unknown. My T2 is 40 degrees Celsius plus 273. All right, this one is 293.0 K, and this one's 313.0 K. Why am I going to the 0.0, 1 decimal place? Because your Celsius, we're in 1 decimal place. Okay, what do I do now? Cancel out my K's and circle my L. Cancel out my K's and circle my L. And then I write down my equation. P1, V1, T2 equals P2, V2, T1. But Ms. Manny, there are no pressures. I know. So what do you do with the P's? Ignore them. Either cross them out or ignore them. It doesn't matter to me which you choose to do. I just need my V times my T2 and my V2 times my T1. So I plug in my 2.30 times my 313.0 equals my V2 times my 293.0. Laura, how do I isolate my V2? Divide both sides by 293. 293.0, 293.0, so that goes away. And it gives me my V2. Isabella, what'd you get for your V2? Okay, 2.4. 2.46. Is that rounded? Okay. And sometimes the way you do the math, you might have gotten 2.46. You might have gotten 2.47. I go back and see that L is circled, so it's 2.46 liters. Why 3 sig figs? Because of that 2.30. 4 sig figs, 4 sig figs, 3 sig figs. My answer only has a 3 sig figs. Okay. The last one's the new gas law that we just learned the other day. It's like moving too much. All right, so let me grab that eraser so that's not in the way. 2.46 is what that volume was. Whoops. 2.46, 2.46, Ms. Matney, 2.46 liters was my answer. All right, this question says, what is the total pressure of a sample of normal air if the oxygen in that normal air mixture has a pressure of 3, the nitrogen has a pressure of 10, and the CO2 has a pressure of 1. So here, I've got to come up with the understanding that 3 gases mixed up together are going to each exert their own pressure, and they exert their own pressure, and when I add those pressures up together, I get a total pressure. So it asks me what's the total pressure when I have pressure of oxygen to be 3, pressure of nitrogen to be 110, pressure of carbon dioxide to be 1. So when I come over here and I just add all those pressures up, I say 3 plus 10 plus 1. If you don't want to do the atmospheres till the end, that's okay. They all have 1 decimal place, so my answer has 1 decimal place. Total pressure ends up being 14.0 atmospheres. Yes? Okay, I need everybody to find their D51, the gas laws, page 2, and turn it over on your back, on the back, not your back. Turn it over on the back. Everybody go find your D51, the gas laws, page 2.